when I talk about the Ice Age, which is my main field, they say people get a chill, so put on your sweaters and your coats. This is actually 2 talks into one, the Ice Age and the woolly mammoths. So secular scientists accuse Bible believers that we can't explain anything that you see out in the real world. They commonly say that. And there's hundreds of these challenges. I beg to differ with them. I found that if you stick to the Bible and gather all the data, a lot of times you can explain it within the biblical worldview. I also find that most of the time they're challenged, even though you wouldn't know that, because a lot of times they'll add a secondary hypothesis to explain an anomaly away. Okay, the Ice Age is one of their main challenges. How do we explain the Ice Age? They say there's been numerous ice ages. They take millions of years. So how do we explain it? Well, first of all, what is an ice age? Well, this is not much of a definition, but it's a great increase in snow and ice. It's difficult to find a real good definition. Actually, 10% of the continents are glaciated today, mainly Greenland and Antarctica. During the Ice Age, it was 30% of the land. Practically all of your country was glaciated, but there were a few places that weren't, like the Yukon Territory, places in the Yukon. Also, it's the last major event in Earth history, and I'm going to revisit this. The last major event in Earth history. But first of all, was there really an ice age? You know, some Christians say, I can't believe there's an ice age because they claim it takes millions of years and we don't have millions of years, so I'm not going to believe it. Well, how are we going to find out? Well, you go to look in areas that are glaciated today and find out what glaciers do. And so when a glacier comes out of a valley, it carries all this debris with it. And it piles it up on the edges, called lateral moraines, and in the front called a terminal or end moraine. So this is the beauty of the Athabasca Glacier. You don't know where that is, do you? Anyway, it's been receding since 1890 due to global warming. I better get on, just talk about that for 1 minute. Global warming is real. It's been small. They use these climate models to extrapolate into the future what carbon dioxide buildup will do. And those computer models, and I've worked with weather models all my life, are flawed. They can't get clouds right. They can't get the solar and infrared radiation correct. Ocean processes aren't quite right. So they got to estimate things. And when you estimate things in a model like this, it adds error with time, builds up with time. So the models are greatly exaggerated. And I'd say half of global warming is due to natural processes on the sun, ocean currents, variable volcanism in the particles that get up in the stratosphere. So about half is due to natural processes. So the upshot of it is that we have plenty of time to do more research on this. And it's not something we got to act on quickly to save the planet, as some people think. Anyway, I better stop there. Anyway, here's what you see there. You see all this rocks of various sizes piled up. This is called ground moraine. See, my cursor shows up. Yeah, okay. This right here is in the front of the glacier. It's called an end moraine. And right in here is a lateral moraine along the edges. And here's that lateral moraine right there. You can see that it got some boulders in there. It's very sharp. It was recently made. And in glaciers, they have debris that's on the bottom, and that debris scrapes over bedrock and it gets scratched. They call them striations. And the boulder might move in the bottom of the glacier and get stretched in different directions. Like this one right here at the Athabasca Glacier, the Columbia ice fields. And it scratches the bedrock in the direction of movement. So those are features we see in glaciated areas today. So do we see features like that in areas that they say were glaciated, like northern United States, the prairies? Yeah, this is near Augusta, Montana. This is the Rocky Mountain front in the background. And here is a mound of debris just sitting there out on the plains that are supposed to be flat. And it's connected over in here. It broke through here probably because it dammed up a lake when the ice age was melting and broke through. And so they put a reservoir there. And you look at this, and it's got rocks of all sizes in a finer grain matrix, similar to what we see at Athabasca Glacier and other places. Also, you see rocks that are scratched, striations in different directions. Also, if you climb up on the Rocky Mountain front and you see the bedrock and you see the scratches are still there, they haven't weathered out yet, meaning the ice age wasn't that long ago. And here's a few nice pictures of glaciated features. This is the top of the Sierra Mountains. In fact, this is so scratched, it's polished. And you can see erratic boulders sitting on this. And this is the northeast Oregon, the Wallowa Mountains, which were glaciated. Many mountain ranges in the western United States were glaciated. And this is the overdeepened Wallowa Lake. And it has a horseshoe-shaped mound around it. And when you go down to near the lake bottom, you see that the size of this, these are the trees for scale, that is a lateral moraine 600 feet tall, meaning the glacier that came out of that valley was probably about 2,000 feet thick. And when you look at the material in the moraine, it's the same sort of thing, rocks of all sizes in a finer grain matrix. By that I mean sand or mud or silt around the big rocks. They call that glacial till. That's the jargon they use for that. And then you have all these erratic boulders. This is one of the most famous ones, Okotoks erratic, southwest of Calgary, Alberta, Canada. Yes, I have a lot of pictures from Canada. Yeah, this is very sharp. It didn't roll down by water, or it'd just be rounded. And here's a famous erratic called Bubble Rock in Acadia National Park in Maine. And one feature, when ice moves rapidly, it streamlines the surface. And this is south of Lake Ontario in New York. You see all these lens-shaped hills. They're about 100 feet tall, maybe a mile long, and they come in huge groups. Those are associated with glaciers. And in the Puget Sound area where I grew up, this is a LiDAR picture of Hood's Canal near Olympia, Washington, without the vegetation. It's streamlined. In fact, it's probably streamlined all the way up to Canada, which to me says that the ice built up here in British Columbia, and it surged down probably across a lake that it formed, surged down to Olympia, Washington, because these features are formed by glaciers moving quite fast. Anyway, when it's all said and done, the Ice Age was a real event, and it's on the surface of the Earth, and this is a general area of where it occurred. Practically all of Canada, like I said, except the Yukon Territory up in here. And the lowlands of Alaska were not glaciated, just the mountains. This is a schematic. It's not meant to be exact because many of the mountain ranges in here were glaciated. What's the significance of the lowlands in Alaska being unglaciated? Never glaciated. Well, when they run these models, the lowlands and the mountains glaciate. So why weren't they glaciated in the lowlands? It's because they have the wrong model. That's the problem. And that is where you find the woolly mammoths and the bisons and the horses in the permafrost in the lowlands. I'll say more about that later. In Europe and Asia, here's where the ice occurred. Over a lot of the Central Asian mountains and Northwest Asia, most of Northern Europe, the Alps were glaciated. Many other mountain ranges were glaciated. I don't show them all here. It's just a schematic. But notice, here's Siberia up here, and the lowlands were not glaciated there either. And that's where you find the woolly mammoths and the bisons and the horses and 40 other mammals, by the way. The mountains were glaciated. So why? They don't really know. But I believe we know. Okay, there was an ice age. It has to be explained. Like I said, when I examine a challenge, by the way, the Lord has led me over 50 years to examine challenges that they give us, not necessarily to talk about evolution. I find evolution's easy to refute, really easy. But I like to deal with what they say. They tell us, explain that, explain this. Well, okay, that's what I've been working on. I'm mainly a researcher, so I read about 50 or keep up with 50 earth science journals in the Montana State University Library in Bozeman, Montana. So the first thing I discover when I'm examining a challenge, they're challenged too, like I said. So can they really explain the Ice Age? You know, you go to a class in glaciology, the professor might say, oh, cool the earth down a little bit, presto, there's the Ice Age pop up just like that. No, it's much more difficult. Experts in the Ice Age will tell you differently. First of all, we have to know what causes an Ice Age. What are the requirements for an Ice Age? First of all, you have to have cooler summers. Most areas, winters are cool enough already. You have to have much greater snowfall, and it just can't get a climate change just for a year. It's got to persist for many years. That's a pretty tall order, especially when I tell you what the magnitude of the summer cooling is. So Minneapolis, Minnesota, this could be like any place along the edge of the ice sheet, probably even Vancouver here. What do we need? What kind of a temperature drop do we need for the ice to build up? Well, for Minneapolis, the average between the max and the minimum is 70 degrees Fahrenheit in the summer. But because of all the sunlight, snow melts mainly by the sunlight, and there's a lot of it in the summertime. So you gotta cool off the summers below 32 degrees Fahrenheit to get snow melt. How far down? Well, I went to an article from Antarctica, from the journal Quaternary Research, and it said, this is the lowlands of Antarctica. When does the ice start melting in the lowlands of Antarctica along the coast? In the spring, when the temperature is warming up. When it gets up to 14 degrees Fahrenheit, you get net melting. So you have to cool the temperatures off to about 14 degrees Fahrenheit in Minneapolis. But I'm going to be more conservative and say just 20 degrees, kind of round numbers. So you have to have a summer temperature drop of 50 degrees Fahrenheit in the summer. Where are the secular scientists going to get a temperature drop like that? So you're starting to get the picture. This is a major challenge to them. In fact, it's well known. The experts in the Ice Age, like J.K. Charlesworth, he wrote a 1,600-page book on the Ice Age called the Quaternary Era. Quaternary is their jargon for the time period of the Ice Age. He says on page 1,532, Pleistocene. Oh, by the way, Pleistocene is another jargon for the Ice Age. So Ice Age phenomena produced some great theories, an absolute riot of theories, ranging from the remotely possible to the mutually contradictory and the palpably inadequate. And they, by the way, they have 60 theories on the origin of the Ice Age. That might give you a hint that maybe they really don't know. There's only one other aspect of Earth science that has more theories, and that's the extinction of the dinosaurs. There's about 100 theories on that. But that was in 1957. And we know so more now, right? This is modern era. Oh, well, let's get something a little, I can get quotes clear up to almost the present time. But this one, and by the way, this is an abbreviated talk. I'd give you more quotes. U.S. News and World Report in 1998 reported on the top 18 mysteries of science. By the way, did anyone read that cover carefully? Yeah. Why is that a mystery? Exactly. They can't figure out why there's two genders. But you know, that's where we have it hands down on there, our worldview, because it says in the Bible, right from Genesis, God made us male and female. And by the way, they write journal articles and maybe a few books on this every year trying to figure out this great mystery. But anyway, one of their 18 is what causes ice ages. And of course, they believe in many ice ages. So the ice age is a big deal to them. But they can't explain it. That's why it's still a mystery. But can we explain it? Can the biblical worldview explain the ice age? You all know what a worldview is, right? Your view of the world, essentially. Your attitude and what you believe about the past kind of almost determines what you see when you do research about the past and what you see when you look at rocks out there in the field. Well, first of all, we have to put it in our time frame. As I've already strongly hinted, those striations are on the surface. They haven't been weathered out. They're on flood rocks. Flood rocks are pretty thick in North America, probably averaging 1,800 meters on the continents, even areas that don't have any sedimentary rocks like the Canadian Shield. So it's definitely after the flood. So we place it in a transitional climate between the flood and the present climate. So that brings up the strong possibility that maybe the flood was what caused the ice age, the climate change from the flood. Well, how so? Well, the flood was a gigantic volcanic event, and meteorite impacts occurred. So at the end, you'd have all this material blasted up in the air, but the larger particles will settle pretty quick, weeks to months. But they'll still reflect some of the sunlight back to space, cooling the land. But fine particles called aerosols, which are 1/millionth of a meter, they end up in the stratosphere and they float up there for quite a while, and they sink slowly by gravity. So after the flood, you'd have all these aerosols up there, and they would cool the land mainly in the summer. They don't have any effect over the ocean, and they don't affect the winter. Also, the fountains of the great deep, whatever, we're not quite sure what that is, but it's adding warm water from below, or, well, we know there's a lot of volcanism. So all this is going to heat the ocean water. The pre-flood ocean water was probably warm to start with. Maybe it was 20 degrees centigrade on the average. Now the ocean today is 4 degrees centigrade. So if you start with a warm ocean, you add some volcanism and some water from down deep, like in the Yellowstone National Park coming up, you're going to cause a warm ocean. The significance of a warm ocean is the warmer the water, the more the evaporation. And it's the evaporation of the ocean water that produces the precipitation on land. And the greatest difference will be at high latitudes, because the ocean water is going to mix during the flood. So it's going to be pretty uniform, warm water from pole to pole, top to bottom. Arctic Ocean would probably be warm enough to swim in after the flood. And you can evaporate 7 times as much water vapor into the air at an ocean surface temperature of 30 degrees centigrade than at 0 degrees centigrade. Flood volcanism. We have 700 stratovolcanoes like Mount Rainier, Mount Baker around the world, and they're mostly probably all post-flood volcanoes. And they're all giving off more particles into the stratosphere to keep the cooling going for a couple hundred years. So it's going to persist. So this fulfills the mechanisms for an ice age. So here's a few little illustrations, stratovolcano, and here's reflecting sunlight off the dust and aerosols in the stratosphere, reflecting some of the sunlight back to space. It doesn't affect the infrared radiation. That's that squiggly line. That's what causes the cooling of the land. And so you end up cooling the surface. So you have all the ingredients for an ice age. And so here's a little schematic for that. You have warm oceans at a high latitude, lots of evaporation, sunlight reflected from not only clouds but particles, lots of snow on the cold land. So in a nutshell, that's the ice age. So how rapid was the ice age? I mean, they say each ice age takes 100,000 years. Do we need 100,000 years for an ice age? Well, this is my evidence that it was really rapid. This is it, Jenkins. Indisputable proof that the Ice Age caught these people completely off guard. Oh, well. Anyway, what I did was I actually solved some equations. They're called budget equations for the ocean and the atmosphere. The way they work is that you add up all the heating and cooling terms for the ocean, and you get a change in temperature, change in time. So if you can estimate the change in temperature, which I did, 30 degrees down to 10 degrees to reach glacial maximum, that's a cooling of 20 degrees centigrade for the ocean. And then I added up all the cooling and heating terms, and that's what I got. It's like in this room, you turn on an air conditioner, and you turn on the heater, and you find out which one's stronger, and then you'll have a change in temperature, change in time in the room. Well, in this case, the air conditioner wins out. It cools, so the ocean cools. And so these are some of the numbers I got with this budget equation. And there's no way to be accurate with these things because we weren't there. So I used outrageous limits, maximum minimums, because I wanted to bracket it in the middle. So there's the range I got to time to reach glacial maximum, and the best estimate, about 500 years. And then the average depth of the ice, same way. The major variable for determining the snow piling up is the reflectivity of the snow, called the albedo. And there's the range. The best estimate in the northern hemisphere is 2,300 feet. Now that's an average. Some places were probably very thick, like New England, but where I live, Montana and adjacent Alberta, the ice was thin. The reason we know that is because some of the mountains in north central Montana were sticking above the ice. The Cypress Hills of Alberta and Saskatchewan stuck up 100 meters above the ice in the western part. So the ice was very thin in Alberta and Montana. Here's the figures for Antarctica, the range and the best estimate, 3,900 feet. And to melt, it melts pretty fast once it gets going because the albedo, or the reflectivity, decreases, so you absorb a lot more solar radiation. You get a lot more sunshine because there's less volcanic ash and aerosols. So it melts fast. So along the edges, the periphery, it can melt in about 70 years. Interior Canada, interior Scandinavia, about 200 years. So the total time for the ice age is about 700 years. We don't need 100,000 years for an ice age. But was there more than one ice age? Well, I actually believe there's two ice ages. One before the flood around the Garden of Eden. This is the Earth's first ice age. Okay, I gotta explain this because I don't want to insult anybody, but when we were first created, when sin hadn't entered in yet, our communication was perfect. But because sin is in the world, we don't communicate so perfectly anymore. In general, women have sensitivity issues and men have clueless issues. And if you ask my wife, of 56 years, she would say I'm one of the clueless males. Okay, we'll leave it at that. Anyway, let's get serious here. I went to an article published by 6 geologists from the University of Alberta, or in Edmonton, and it was published in Geology. And the title of it was a single Lake Wisconsin Laurentide glaciation, Edmonton area in southwestern Alberta. Now I got to translate that for you. The ice sheet from the central and eastern Canada is called the Laurentide ice sheet. And their time, the Lake Wisconsin, is when they think there's only one. And so this is what they said in that article. See, they used to say there's 4 or 5 of them in Alberta, but when they looked at it a little closer, they found out, oh, just one, because one ice sheet can move a lot, and it can produce a lot of things that look like multiple glaciations. So they made some mistakes in the past. They said glacial reconstructions commonly what? Assume a multiple glaciation hypothesis in all areas that contain a till cover. They've been assuming it. So they see some glacial till here, and then maybe a layer of sand in there, and then maybe glacial till. Oh, 2 ice ages, presto. No, I said one ice age can do all that stuff. So now they've backed away from that, and now in most areas on land, it only shows 1 ice age. They get the idea of multiple ice ages from the bottom of the ocean. They send these deep sea cores down, and they get these variables that down in the mud, and they go like this down in the core. When the variable wiggles this way, it's an ice age. When it wiggles this way, it's an interglacial. So they get a lot of these wiggles, and so presto, it went from 4 ice ages. Now they believe there's 50 ice ages. So anyway, it's kind of crazy. Anyway, these are some of the bonus features I could talk about if I had more time, and I'm going to talk about one. But this model of the ice age could explain other mysteries. For instance, deserts were once very wet. The Sahara Desert had big lakes and rivers and aquatic animals, hippos. Even a live crocodile was found in a playa lake, which is a dried up lake that's only a lake when there's a lot of precipitation. In some of the Sahara Desert mountains, they found a live crocodile in about 1900, still living in the Sahara Desert. You believe that? Anyway, another interesting, disharmonious associations. What in the world are those? Well, that is the associations of plants and animals from different climates together in ice age debris. You have warm climate animals next to cold climate animals. Now, this is very difficult for them to explain. In fact, their ice age models, they have it so cold winter and summer that I don't even think the cold-tolerant animals like woolly mammoths, reindeer, muskox would even be able to live close to their ice sheets. But what about all those warm animals, warm climate animals? The most outrageous example is hippopotamus fossils found in glacial debris in northwest Europe. There are 100 locations, at least, in England where you have hippo fossils with woolly mammoth fossils in the glacial debris. How would that happen? See, hippos are denizens of the tropics or subtropics today and even in historical times. So what would they be doing during the Ice Age up there in England? Well, because remember the warm ocean, warm onshore flow. You wonder why you get so much rain here? You get cool onshore flow, about 50-degree water out there in the Pacific. But what if the water was, say, 80 degrees Fahrenheit in the North Atlantic? You'd have warm, wet conditions in England. So after the flood and the animals spread from the mountains of Ararat, hippos could go northwest because it wasn't cold. Winters would be a lot warmer, and they would find nice places to live until it got colder and colder. And then the woolly mammoths started coming in, and the hippos didn't know where to go. And so they all died together during the Ice Age. 100 locations of hippo fossils during the Ice Age in England. That's disharmonious associations. And that, to me, is powerful evidence for this model of the Ice Age, the biblical model, I'll call it. Then there are end Ice Age mass extinctions. Only after their last Ice Age of the 50, you had huge mass extinctions of animals. Woolly mammoths are gone. Saber-toothed tigers are gone. Ground sloths are gone. A huge amount of animals disappeared. On the average, about 66% of mammals over 100 pounds went extinct globally. And woolly mammoths in Siberia, and I'll get into that next. Unglaciated lowlands of Siberia, I've already talked about that. The reason, I'll get into that too. This explains the ice sheets that are still here, like the Greenland and Antarctic ice sheet, and ice cores. Ice cores. And caves. Believe it or not, the speleothems in caves could form rapidly during the Ice Age. And the Lake Missoula flood, which I don't think anyone here has ever heard of. Oh, okay, good. Yeah, it's a popular thing from Montana, where 200 cubic kilometers, no, 2,000 cubic kilometers of water in the western valleys of Montana, 2,000 feet deep, broke through Idaho and carved up eastern Washington, forming Grand Coulee and a lot of those other canyons in a matter of days. Anyway, let's talk about the woolly mammoths now. What happened to the woolly mammoths? Well, there's a woolly mammoth for you. There's another type of mammoth called the Columbian mammoth. He's larger than the woolly. Woolly mammoth is rather a small elephant type. It had unique features, a hump on its head and back, sloping back, long hair, spiraling inward tusks. This is the distribution of the woolly mammoths, the red area. And they're associated with the Ice Age. There's some people that believe they're associated with the flood, but that can't be, as I've written about many times. You don't find them in the central and northern parts of where the ice sheets were, like central Canada, northern Canada, and central northern Scandinavia. You can find them on the edges of where the ice sheets used to be, either before it glaciated there or after it melted back. So the red area, they're hemispheric wide. They cover the whole northern hemisphere. They're especially found in Siberia. Here's a little geography lesson. This is color-coded. The green are low areas. This is western Siberia. I think I want to focus mainly on the eastern part of Siberia, which is rather mountainous. And the mountains were glaciated. And the green area along the coast was not glaciated. Here's the New Siberian Islands here. You can see they got a little bit of that yellow area there, so they're kind of mountainous And there's huge amount of woolly mammoth bones on those islands. And I'll explain that as we go. It's rather hilly, so that's a key feature why there's so many there. Anyway, mammoths are cold adapted. They have long hair, small ears, an anal flap, oil glands in their skin. There was a controversy that maybe they didn't have oil glands. You needed oil glands in that environment, or like an African elephant doesn't have oil glands because he lives in a tropical environment. So if he didn't have oil glands, they definitely would have been a tropical animal. But they do have oil glands. Reason they didn't know that is because their samples of some of the carcasses they found were in poor condition to know that. So here's the elephant dietary requirements. Now, woolly mammoths being smaller probably had a little less, but that's still a lot of food they have to have every day and a lot of water just for one. Now, the Columbian mammoth is actually the largest elephant type of all. It's about 14 feet tall at the shoulder. I think the woolly mammoth is more like 9 feet at the shoulder. So, with one woolly mammoth needing this much each day, how many woolly mammoths were up there, and what does that mean? Was it a small number in Siberia, which wouldn't be a big deal, or a large number? Well, the experts that actually find the fossils up there find so many that they estimate the mammoths just south of the New Siberian Islands in the millions. So that whole area probably had tens of millions of woolly mammoths in Siberia and in Alaska and the Yukon Territory. See, I'm focusing mainly on Siberia because that's where people think that they live, but they lived in Alaska, lowlands of Alaska, and the lowlands of the Yukon Territory also. But there's a lot of mysteries with these mammoths. And these are mysteries that just blow their minds. They just can't explain it. The bones and the tusks are in permafrost, permanently frozen ground. They believe the permafrost has been there for almost more than 1 million years. So how in the world do these animals get in the permafrost? It's like hard rock. And they're well preserved, which means they had to be buried rapidly. How did that happen? And there's been about a couple dozen frozen carcasses. How do you get a carcass jammed into permafrost rapidly? Big problem. Also, the stomach contents are only half digested. And the stomach contents indicate a vegetation from the present area and also from areas further south in a warmer climate. But that's not all. There's actually a wide diversity of animals, just not the woolly mammoth up there. There were about 40 different types of mammals. Some of them were burrowing animals, like ferrets, beavers. Most mammals were grazers. They ate grass. That's why they called the area where the mammoth lived the mammoth steppe, S-T-E-P-P-E. That's a climate where it's a grassland, just like on the prairies out there in Canada and Montana. Wildlife specialists consider them well-dressed giants, healthy, long hair, big horns. Most large mammals went extinct at the end of the Ice Age, like I told you. So, and some mammals that now live much further south. They can't tolerate the temperatures up there, or the environment. The environment in the summer is a bogland because of the permafrost. About the top half meter melts in the summertime and has nowhere to drain, so it becomes kind of a bogland. Animals, it's hard to get around up there. They can, but it's hard. And elephants especially would not be able to get around up there. It'd be very hard for them. That's not all. Well, I'll get to that. But we can make a few deductions. It was a grassland with a wide diversity of plants. See, when you have a wide diversity of animals, you need a wide diversity of plants because they all have special needs. It implies a fertile soil, unlike today. The soil up there today is a bog soil, which is unfertile. high-quality habitat, light competition, long growing season. More deductions. It means the snowfall was light and melts early. Milder, relatively dry winter. Summer bogs rare, implying little or no permafrost until near the end of the Ice Age. That's a tall order for Siberia. See, after the flood laid down its sediments and the water was warm, you're not going to have any permafrost to start with. No permafrost after the flood anywhere. Permafrost is formed by winter temperatures. And evidence that there was a lack of permafrost is the distribution of the saga antelope. The dots are the Ice Age distributions of the saga antelope. Now, the saga antelope has small hooves and can't negotiate permafrost. It needs wide open prairies, like the pronghorn antelope we have in Montana. Here's where they lived during the Ice Age, these dots. Right, and even an island off the coast, right up in here, and even in northwest Yukon Territory, there's one in the lowlands of Alaska, implying a lack of permafrost. So this adds up when you look at the mammals themselves, the carcasses and some of the bones, you discover some were in a standing upright position. 5 animals are known to suffocate by the condition of the blood in the carcasses. Some of the bones are broken, not just leg bones, but sometimes the pelvis is broken. The New Siberian island are huge masses of bone beds, and the lowlands were not glaciated. All these are mysteries to the secular idea of the Ice Age and the woolly mammoths. And here's an illustration from Dale Guthrie, University of Fairbanks, University of Alaska in Fairbanks. This is what they were mining gold up there in Alaska, and the hooves of a horse were sticking out from the ceiling, so they put their lamps on it. But the scientists wondered, oh, what in the world? We want to excavate that. It was 26 feet below the surface. So they said, it's in a general standing position. How in the world did it occur? When they excavated, it had no head. So here's their hypothesis. Remember, a hypothesis can be an educated guess or a speculation. They think the horse got caught in a bog and sunk down with its head just sticking out, and then a cave lion, which is one of the animals that lived in Siberia and Alaska and the Yukon, ate its head off, and then it got covered up with 26 feet of debris. That's what they say. So this is an example of an animal in a general standing position in the permafrost. But it's kind of interesting that in most of the cases, the soil around it is not bog soil. And that's the key to explaining how these animals died, the type of soil that they're found in, which I'll get to. So woolly mammoth, the upshot of all this is woolly mammoth extinction is a major mystery of mainstream Earth science. A major mystery. And here's a few quotes from some secular geologists. Why did mammoths disappear from Earth? This question remains one of the great unsolved mysteries of the past. Here's another quote from 2 Russian scientists saying they couldn't live there today. There would be no place for mammoths in the present Arctic tundra of Eurasia with its dense snow driven by the winds. They just can't live there today. And yet, in their ideas, during the environment up there was not too much different than today. You read their material, it was similar today, maybe a little cooler, maybe a little warmer, but similar today. But that doesn't do it. So how can we explain it? That's the big question. How can the post-flood ice age account for the mammoth mysteries? Well, for one thing, with no sea ice after the flood, It'd be a lot warmer temperatures. The sea ice causes a great cooling in the high latitudes. A man did a computer model where he took off the sea ice in the Arctic Ocean, and he wanted to find out what the winter temperature change would do, but he kept the temperature of the ocean water at the freezing point of seawater, which is 28 degrees Fahrenheit because of all the salt. And this is what he got. This is in centigrade. Near the North Pole, it warmed 40 degrees centigrade in the winter. Northern Siberia is 20 degrees centigrade warmer in the winter. Just with the temperature of the water at the freezing point of seawater. What if the water was 70 or 80 degrees Fahrenheit? It'd be very much warmer in there. So winters in that area would be much warmer. This would also aid the animals rounding the Bering Land Bridge through Siberia into Alaska and down the east slopes of the Rocky Mountains to Alberta and Montana early in the Ice Age, and clear down into South America. That's how they got here. Because the winters weren't bitterly cold up there, they're able to migrate a lot easier. And then if you have all that warm onshore flow, like you have cool onshore flow here, but you'd have warm onshore flow, at least at the beginning of the Ice Age. But as temperatures cool, it'd become cool onshore flow. But it's enough to keep the snow in the mountains and not in the lowlands because of the warm onshore flow. So I came up with what I felt were average temperatures and precipitation for the continental areas. Ignore that green area there. I want to take that out. In fact, I did it once, but I can't find the slide. Anyway, this is what I projected. At the end of the Ice Age, winters are going to be much more than today. Here's the average winters down in here. Much warmer winters. But as time goes on, it cools, and actually gets below today's winters at the end of the Ice Age. This is very significant. Summers, that red line, gradually warm until it reaches glacial maximum and then starts melting the ice pretty fast. So this is a very key factor. It's a very dynamic climate, changing in 700 years, huge changes. And precipitation, with all that warm ocean water and all that evaporation, you're going to get heavy precipitation, probably globally, early in the Ice Age. But as time goes on, it gets drier, oceans cool, and finally it actually goes below normal, becomes drier. And these are very significant features because during this time, the woolly mammoth, their populations mushroomed, but by the end it got so cold and dry that that's one of the reasons they went extinct. So we got to ask ourselves, well, it's a 700-year Ice Age. Is there enough time to produce many millions of mammoths at the end of the Ice Age? By the end of the Ice Age? Well, yeah, I went to some of the preserves in Africa and found out how fast elephants doubled. One, they doubled in 10 years. So if you use your calculator and just keep doubling things, within a very short time you have a monstrous number. It's called geometric progression for those that have taken algebra. Anyway, doubling time is 10 years, you can have 1.3 billion in 300 years. If they didn't die, of course, but there's going to be a lot of that. But 1.3 billion possible if they live that long. It gives you an idea how fast they can multiply even in a short Ice Age. So it's not a problem. So permafrosts, none at the end of the flood. It's the warm ocean still, but by the time you're getting midway in the Ice Age, you're starting to pick up some areas of permafrost. And by the end of the Ice Age, you have a huge areas of permafrost. And after the ice melts, some of that permafrost does melt, forming kind of a hill and hollow terrain up in Siberia, called udamas and alasas, as they call them. It's interesting that much of Europe was in permafrost at the end of the Ice Age. I saw diagram of it just recently, and went clear down into Hungary and further south, permafrost. So it was extensive. I think even in southern England and northern France, they had permafrost. Very cold temperatures would cause that in the winter time for that much permafrost, just like this model would suggest. And here's the woolly mammoth timeline. I believe they're part of the elephant kind that went into the ark. Remember, we don't have to get God did not send all the species in the world into the ark. It was kinds, and a kinds is probably averages at the family level. So you only needed, depending on how you want to factor that in, you probably only needed anywhere from several thousand to 30,000 animals in the ark. It's not a problem when you realize it's kinds, because we know that a lot of these the species and genus, these are man-made categories, and a lot of times we know that a lot of these animals can interbreed. So there's the dog kind. We know that all dogs can interbreed if they were in a cage together. They don't normally do that. Wolves and dogs can interbreed, meaning that they're in the same kind. So it's the kinds that were in the ark. So we have a lot of room on the ark. It's not a problem, even though skeptics will always point out there's not enough room for all those species. It's not species, it's kinds. Anyway, from I believe it was the elephant kind, and from the elephant kind, 2 elephants, you had the genes and the DNA to produce mammoths, elephants, and mastodons. And then so with time, you got your mammoths, and you had 2 types of mammoth, woolly mammoth and the Columbian mammoth, which we know could interbreed, by the way. So, and they define them as different species, but then they should be the same, but they're in the same kind. But it starts slowly, but then it mushrooms with time during the Ice Age, and by the end, when it got cold, drier, windy, they went extinct globally. So that's why I think we had global extinctions because of this dynamic climate change during the Ice Age. So let's get to the big questions. How did they die in Siberia and get in the permafrost? How did that happen? The solution to the mystery of their extinction is found in the deposits surrounding the mammoths. So the experts up there, these 2 Russian guys, said a particular interest for paleozoologists is the edamas. Those are those hills. After the permafrost melts and forms hollows, you're left with hills where the permafrost has not melted. And they say this is actually a loess layer, as a rule containing the largest amount of remains of late Pleistocene animals. In other words, millions of them. What is loess? It's windblown silt. Windblown silt. And areas of the world, 6% of the surface of the world, of the continents, are covered by this. And they're rich agricultural areas like the eastern Washington, the Palouse loess, as they call it. Well, that presents some interesting thing. They died in dust storms, and they're covered up by dust storms, and the permafrost came up into the dust with time. So that we can explain the mysteries by this loess. Well, but then why did we have late Ice Age dust storms? I've already kind of given you some hint at that. Colder winters. See, the animals were not used to colder winters. They were used to mild winters in the north. But when it got bitterly cold, even more cold than today, they couldn't survive. The oceans were colder. You'd have more sea ice. The atmosphere would become drier. And you'd have a stronger north-south temperature difference. The tropics would start warming up, but because of the ice sheets in the north, it'd be cold there still, so you'd have a strong north-south temperature difference. What's the significance of that? That drives the jet stream. The stronger the north-south temperature difference, the stronger the westerly jet stream above you. And that jet stream sometimes hits the surface. Well, not quite the jet stream, but the lower parts of it will hit the surface. You can have strong winds. So the upshot of this is you're going to have strong dry, cold fronts. And that's where you're going to pick up the dust that's going to cover the woolly mammoth, like this from the Dust Bowl era. This was a scene many times. How would you feel if you saw that coming at you? You're out there in your field plowing. It might be dangerous. Anyway, I think that small to medium-sized dust storms explain how the bones and tusks were buried rapidly after undergoing natural decay. A lot of them underwent natural decay. And it piled up. And that's how they ended in the permafrost, because it's not frozen yet, but the whole area is becoming colder and colder. So as it's piling up, it's freezing, and it's freezing the animals within it. And they do it rapidly, so that's why they're well preserved. I'm going to show you a schematic later on, kind of show this, but during the Dust Bowl era, there were dust blizzards, kind of like some of the blizzards you see on the plains today. Here's a huge dust drift from the Dust Bowl era. So that can explain some of these other mysterious features, like stuck in a standing position in a dust drift. If you're a woolly mammoth, you get caught in one of these dust blizzards, the dust is going to pack around you, and it'll pack tightly. Snow in a snowdrift packs tightly too, by the way. Also, they're going to breathe this dust and suffocate. And they'll end up frozen in the dust. Is there evidence of suffocation by dust? Just recently, they found two-month-old baby woolly mammoths in Siberia, 5,000 kilometers apart. They died of asphyxia or suffocation. And how did they do that? Oh, they had some ingenious ideas of what in the world? They said they found mud packed in their mouth, trunk, oral cavity, and lungs. How in the world would they? Mud can be another name for wet dust. So these animals died during dust storms. The New Siberian Islands were hills, and as ice was melting rapidly, sea levels rising rapidly. And the New Siberian Islands were hills because of the lower sea level, exposing the continental shelf. But as the sea level rose, and they realized it was rising, they would head for higher ground, which would be the New Siberian hills. But they got cut off from the mainland, and those higher hills ended up being islands, and there were too many of them. They died by the tens of thousands in the New Siberian Islands. Two mysteries are left. How is the half-decayed stomach vegetation explained? And how are the broken bones explained? Well, the digestive system of a mammoth, mastodon, and elephant is different than what we would think. Here's a quote from a book on that topic. The digestive system is based on post-gastric hindgut fermentation, in other words, after the stomach. The stomach is large, but serves mainly to store ingested food. It's just a storage pouch. Enzymes within the stomach partly break down the vegetation. That's why the stomach vegetation is partly broken down. Some people thought it had to be instantaneously frozen to be in that condition, but no, it's because of the type of stomach of this animal. But most nutrients are extracted in the huge cecum and large intestine, where microbes ferment the food remaining after gastric processing. It's the digestive system of the elephant that can explain the stomach contents. So there's some woolly mammoth had broken leg bones, and also one had a broken pelvis and ribs. How did that happen? Well, there is in the United States near the Black Hills of South Dakota, called Hot Springs, there's a sinkhole that filled up with windblown silt. And there's at least 100 mammoths in it that fell into this sinkhole and got covered up. And some of them had broken leg bones. So this expert, Larry Agenbrod, thought that it could be to two processes. We can eliminate number two, but notice the first process. He thinks that their leg bones are broken by torsional stress, trying to extricate a limb mired in mud, muck, quicksand, etc., probably even enhanced by an accompanying accidental fall. In other words, trying to get out of the mud that he fell into the sinkhole, he broke his limb bones. And that can happen as the woolly mammoth is being covered by windblown silt. It's packing tightly, and he's trying to get out of it. And the process, the torsional movement on his limb breaks his leg bone. But what about the pelvis and the ribs? Well, it's known that permafrost faults, shifts like that. And these two Russian scientists say after burial in the permafrost, the organic remains could have shifted vertically within a wide range owing to their physical properties and the features of the permafrost environment. It is now known that in frozen ground, bones and pieces of wood are sometimes shifted vertically by 10 to 15 meters along the boundary of the frozen ground and ice veins. Okay, that's a lot to take in. So here's a little schematic to try to summarize it for you. We got a woolly mammoth out there peacefully eating grass and buttercups. Yeah, they find grass and buttercups in their mouths and their stomach. When the wind's picking up, a cold front just came in. I'm going to turn my back to that. Oh, but I'm acting like a snow fence. I'm breathing that stuff. I'm suffocating in a general standing position. And more dust storms keep piling up until he's well into the dust. And the permafrost, that blue area in the bottom, and from colder air from the top, both come up and freeze it. So he's automatically put into permafrost. And it faults, breaking his pelvis. So that's a schematic on how I believe from this Ice Age model that you can explain the extinction of the woolly mammoths in Siberia. So, why can't mainstream geologists see the importance of the loess? Because you don't get loess up there today, hardly. You don't get much wind-blown silt. In fact, Dale Guthrie, in this 1990 book, Frozen Fauna of the Mammoth Steppe, said these large bones could not be preserved by a few millimeters of annual aeolian loess fall. Their preservation requires large quantities of reworked silt. He gives it a few millimeters. I'd have to say that there is not even that much blows around there today. And they use conditions today to explain the past. It's called uniformitarianism. How many have heard that big word before? Not too many. It's how they explain all the rocks, fossils, and the climate they deduce from the rocks and fossils by present processes we see going on today, extrapolated into the past, called uniformitarianism. That is the main assumption of geology and paleontology. And that's the main problem because they've thrown out the flood and the creation in the process. And they cannot see because of their stretched out time scale. See, they know that they're in wind-blown silt, but if they stretch it out to their ice age to 10,000, 100,000 years, each event is only extremely small, a few millimeters, and Dale Guthrie is very generous. That's not going to be good enough to preserve these. It's because of the stretched out time scale. But what if you bring the time scale back to, say, a few hundred years? It becomes a powerful mechanism to explain all these features. It's their stretched out time scale that keeps them from seeing the deductions you can make from what you observe up there. Time is not a side issue, but crucial for solving mysteries, as I have found in quite a few different areas of Earth science. In summary, the Ice Age was a real event not that long ago. They have to explain it, and we have to explain it. But to them, it is a major mystery for evolutionary Earth science. Noah's flood caused a transitional climate for an ice age. The Ice Age lasted only 700 years. We don't need 100,000 years for an Ice Age. There was only one Ice Age, and so the Bible explains the Ice Age because of the flood. And there will be no future Ice Age. Concluding thought, creationists have a viable mechanism for the last major event in Earth history. Remember I made that point at the beginning? Well, evolutionary scientists are far from a solution. We can explain the last major event. Then, why should we believe them for all those older events? Like the extinction of the dinosaurs, the evolution of this beastie, and the extinction of this one. I mean, they have a whole bunch of these things if you read their material, which I do. So why should we believe any of them if they can't explain the last major event in Earth history? The Ice Age is an example of what can be done with hundreds of other science challenges to the Bible. You might not know about these, but there's probably, since I read the literature, there's probably several hundred. I've worked on many of these, and they have solutions. And that's why we have answers books out there, because we can answer many of these, but many of them we can't. And there's reasons for that. Number one, Earth science, there's a lot of unknowns in Earth science. We don't have enough researchers to research it. So a lot of these challenges no one's actually looked at yet to even come up with a solution. So those are some of the reasons we still have Earth science challenges. And not only Earth sciences, there's biological challenges, astronomical challenges, and living in the culture today, there's cultural challenges for Christians, right? Time is not a side issue, but a young Earth timescale sometimes is a key to solving major mysteries that have lasted over 150 years. The Ice Age is based on the flood. Therefore, the flood, one of the most despised events by the culture, is a real event of the past. If we can believe the flood, a global flood, it is easy to believe the whole Bible, which tells us how to live here on earth and how to go to heaven. We can believe the whole Bible. And being in this field for 50 years as a researcher has greatly increased my faith, by the way. The post-flood rapid ice age can account for the lowlands of Siberia not glaciated, why mammoths even lived in Siberia in the first place. They couldn't live there today. Why there's abundance of food in Siberia. It's a grassland. Why there's a mix of warm and cold climate animals. How mammoths and other animals went extinct explains all the Siberian mysteries. Conclusion, reasonable explanations for the many mammoth mysteries are provided by the post-flood rapid ice age. This ice age is a climatic consequence of Noah's flood, etc. Supports the Bible and against the present processes over millions of years alternative hypothesis. That's uniformitarianism. Present processes extrapolated in the past over millions of years.